Hi and welcome to the second video in this series. Last time we saw the simple variable declarations in Fortran. Today we'll be seeing the intrinsic operators for math, logical operations, and string operations. So let's create a file. So let's name it operations.f90. Remember F90 for the freeform Fortran. Let's start with program, operations, and we have to end program operations. Again, the space in end program is not required and Fortran is case insensitive. Implicit none to specify that we're going to have to declare all the variable types and we do not have any implicit naming convention. Let's go with reals. We have gone through the precision definition last time. I'm just going to use the defaults for this one. And let's say x, y, and z. Let's go with a boolean. That would be logical in Fortran. So bool 1 and bool 2. Let's go also with a character string. So word 1 and 2. Alright, let's give this some values. Alright, so let's define the math operation first. We have the addition, subtraction, multiplication, division. Those are the basic math operations, just as in school. The only weird thing, perhaps for those who are not used to this, is a double asterisk for exponentiation, but it is a generalization of multiplication, so that should be not too hard to get your head around. For the logical operations, we have the .not, .or, .and, .equivalent, and the not equivalent operations. So we can have a string and negate it. We can have two strings, use an or, an and, an equivalent, and a non-equivalent. Those are the basic intrinsic Fortran operations. You can also have more complex operations, such as an exclusive OR, but that's just a function, and we will get to that later. As for characters, we have the concatenator operator, which is denoted by a double slash, and this only joins two words. So let's say we have here an extra word. Let's call it result. We would have to use result is equal to, say, word 1 concatenated with word 2 and print this result for later. We're going to leave this for later. As for the math operations and logical operations, I believe you will not have too much trouble with that. So let's just print a few results. And that's that. So let's just compile and print this. Fortran, the name is operations, and the output, let's just have it as the normal a.output. So .a, and here we get the results. So indeed, x plus y, x minus 1, x minus y are as we have intended. X times y, x divided by y. We get all those results in the default precision. We have gone over the precision specification in the last video. And as for z, you can notice we have an exponential notation or scientific notation with the 4.16 couple digits and the e plus 11. That would indicate a times 10 to the 11th power. For the Boolean operations, the AND obviously returns a false because we have a false and a truth. For the OR, we get a truth, that's correct. And for the word concatenation, we actually did not specify here the length of these words, so we only have the T of the first word. Let's specify, say, 10. Actually, we'll need a bit more than that, say 18. And let's recompile and re-execute. This is... Alright, I see what I missed. word 1, word 2, and result were all allocated with 18 characters as specified in this line above. So word 1, even though we have only written 8 characters for this string, we have the other 10 characters which are empty strings by default. And the same for word 2, we have allocated 9 characters. The rest of the characters are all empty strings, and for the result we only have empty strings. So there are a couple ways to fix this. The simplest way, and the way we have also hinted at in the last video, is to use a substring. So say here from 1 until 8, that will give us the first 8 characters. And for word 2, we have the same from 1 to 9. That should work. I'm going to write, compile, and execute. Yes, now we have indeed the correct result. There's another way. We could have alternatively explicitly said that, say, word 1 and word 2 were of less characters. This is the second way. We have 9 characters for word 1 and 9 characters for word 2. We have explicitly assigned 7 characters for word 1, which is the partial phrase this is, which would give us 2 extra spaces at the end. And both of the character lengths add up to 18, which is the explicitly defined character length for result. So here we would go and just delete this subarray specification, which would not hurt really in this case, but it is not the intention of this example. Compile and execute. As you can see, we get the phrase this is example, but with an extra empty, rather space in the middle. So the first way with the substrings is the one that gives you the most control. Now let's take a closer look at the operations for numbers. There's a slight subtlety which I did not really specify here, which is the fact that we are actually operating all with real numbers. If we want to, say, operate with integer numbers, we would actually get a couple of inconsistencies, or at least something that you might not think that would come about from these operations. So let's just print 1 over 2, right? We would expect to have 1/2, but 1 is specified without any precision, without any kind, so by default it is an integer of simple precision, as well as 2. So if we compile and execute, we get 0 as a result, as you can see right over here. The reason for this is very simple. Here we have an integer division between 1 an integer and 2 an integer. If we wanted to have a division between, say, a real, we could have selected 1 point, which we have discussed in the previous video. This is now a real of default precision. So we can write this, we can compile and execute. Now we get 0.5. The reason for this is that Fortran has a real number divided by an integer number, so before carrying out the operation, it converts to a common type, which is in this case the real, and so the 2 is converted implicitly to a real 2, and the operation 1 divided by 2 in real precision with real kind is carried out, which turns out to give a 0.5. As per these specifications and type conversions, from integers, Fortran converts to reals, and from reals it converts to complex, or from integers to complex as well. If you have an operation between different precisions, the resulting precision will be that of the highest precision, which can lead to a couple errors. You can have rounding errors or truncation errors because of the implicit type conversion. To finish up, there's a couple of comparison operators. We have the equal operator, all this for numbers, the not equal operator, the less than operator, the greater than, less than or equal to, and the greater than or equal to. For older Fortran standards, we have the dot equals, the dot not equals, the less than, the greater than, the here we have less than or equal to, the greater than or equal to, and that's all. This is simply an older notation. For Modern Fortran, these symbols explicitly are a bit more, well, common practice. So that's it for this video. I hope you've enjoyed it, you've taken something out of it, and I'll see you next video in which I'm going to be talking about conditional statements in Fortran.